Welcome everybody. Today we're going to be looking at uh, relations again, and even though we're starting a new unit, this unit is going to also focus on relations, but more specifically linear relations. So go ahead and read this, and just to see what's going to happen in this unit. One thing I do want to point out is that uh, you already know this. So a linear relation is a relation whose graph is represented by a straight line. So the two definitions of graphs that are linear, and then if it's not a straight line, if it's a curved line like something like this, maybe you have a parabola like that, where all we know now is how to define that is by saying non-linear. So let's go ahead and look at some line segments here, and again, a line segment is a line that has a finite endpoints. So even though a line can continue going on forever, when we say a line segment, we're just referring to a portion of a line with specific start, with a specific start and an end. Okay, so how do we calculate a length of a horizontal line? Okay, well, let's look at this first line AB here, and there's a couple ways of doing it. You can go ahead and count it. If you start here, 1, 2, 3, 4, 5, 6, well, the length is 6 units, but a better way might be to go to look at the x-coordinate over here and the x-coordinate over here, and just subtract the smaller one from the bigger one. So the x-coordinate here would be 8, and then we're going to subtract this one, which is 2. That might be a quicker way of getting it. Okay, if you have a long line segment, it's going to take you forever to count. So this is a quick way of doing it. Okay, so let me go ahead and I'll do this one here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that took me a while. Or I can just go look at the x-coordinate here, and that's 7 minus, look at this x-coordinate over here, it's -3. And 7 minus -3 is 10. So it's a little bit quicker way of doing it. Okay, you guys can all do this last one over here. Okay, and I think that's what they're trying to get you to do here for part B and for part C. They're getting you the x-coordinates, and then you're just subtracting them to get 6 and 10. Okay. So how can the coordinates of the endpoints of a horizontal line be used to find the length of a line segment? Okay, you can just subtract the smaller one away from the bigger one to get the entire length. Okay. Okay, so let's do a couple here. So if we have, if AB has endpoints of 2, 8 and -5, 8, determine the length of AB. Well, I can graph that. Do a rough sketch over here, and I can graph 2, 8 might be somewhere up here, 2, 8, and -5, 8. So -5 might be here, 8 again. So this will be A and this will be B. -5, 8. So if you can somehow visualize this, all you would have to do is go 2 minus -5 to get 7. Okay, or you can count, if you had a good grid here, you can actually count and get 7. But again, that's going to take you a really long time. So we're looking at the x-coordinates, and that's the smaller one, that's the bigger one. So we subtract the smaller one away from the bigger one. Okay, same thing over here. Determine the length of line segment. Okay, so this is no, they're getting a little fancy here, trying to throw you off. Well, if that is the x-coordinate, that is the y-coordinate. So the y-coordinate is the same, which means it's a horizontal line like that one up here. So we're going to take the bigger one, which must be a plus 4, and subtract away the smaller one, which is a minus 2. Don't forget to use the bracket here, because you're distributing this negative sign into the bracket there. Okay, and then we get a minus a disappears, and 4 plus 2 equals 6. Okay. All right, well, vertical line segments are basically the exactly same strategy. You know, if I were to do this one here, GH, I can count the number of spots: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, that's going to take a really long time. Or I can just take the bigger one, the bigger coordinate, which in this case is 4 minus -8 to get 12. Okay, so same strategy works for vertical lines as it does for horizontal lines, except now we're looking at the y coordinate. Okay, I'm going to go ahead and skip this. I think you guys can all count those or do subtraction. And then basically this is the exact same thing except for the y coordinate. How can the coordinates of the endpoints of a vertical line segment be used to find? Well, we're going to look at the y coordinates and subtract the smaller one away from the bigger one. All right, let's do a couple more questions. Okay, line segments, RS has endpoints 1 and -4 and 1 and -9. Determine the length of RS. Well, I see the x coordinate is the same. If the x coordinate is the same, it means it's a vertical line because it's not moving anywhere horizontally. So let me go ahead and find the bigger one. The bigger one of the two is -4 minus -9 to get 13. Okay. Determine the length of the line segment. You're always, sorry, by the way, you're always going to get a positive number, right? Because you're subtracting a negative number away. You can't have a negative length of anything. So think about that. You're always going to get a negative number. Doesn't matter what the numbers are. All right. The way you arrange it, if it's 5 and negative 20, you're still going to go 5 minus -20 to get 25. So there's no way to get a negative number when doing this. Okay. And again, if you have variables as your coordinates, double check that your x coordinate is the same, and then take the bigger one minus the smaller one. So b plus 10 minus b equals 10. Okay, vertical lines and horizontal lines are very convenient, but sometimes you're going to get a diagonal line. Most of the time you're going to get a diagonal line. So we need to look at how to get those, and obviously we can't count because I'm not really going up by increments of 1 here, because look, this doesn't exactly fall on the coordinates, on the actually what's called the lattice points, which are any of these points are called lattice points. So if the line goes through the middle, I'm not really sure what the measurement is there. So we have to do Pythagorean theorem, which we all recall is a squared plus b squared equals c squared. But let's just review again what a and b and c are. Okay, this only works if you have a right triangle, which means a triangle with a 90-degree angle here. Okay, and then the long side, which is called the hypotenuse, is located away opposite of that 90-degree angle. So what the theorem says is that if I squared the short side, okay, there's a short side, a squared, and I add the square of the other short side, that should equal the squared of the c side. Be careful. This does not mean that a plus b equals c, okay? It only works if I square everything, okay? So let's go ahead and use that information to calculate the distance of diagonal lines. Okay, so this is going to be a little tricky at first here. First need the length. First need to draw the triangle. Okay, well that is the hypotenuse, and I'm going to draw an imaginary triangle like this and mark my right angle here. And now I need the measurements of A and B, or the two short sides. And again, it doesn't matter which one is A and which one's B, as long as you know which one is the long one. The long one is over here, and that would be the C side, or the hypotenuse. Okay, so let me go ahead and label this, and I'm going to label this, I'll label this A, and I'll label this B, and I'll label this C. So the length of A is, well, I'm just going to quickly do a little count here. 1, 2, 3, 4, just because I can. It's going to be a little quicker. And B, well, B I might not count. I'm just going to go 7, and Y7, because that's the Y coordinate, minus -3. So 7, I can do that off to the side here. 7 minus -3 equals 10. So B equals 10, and I can double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now I got my two short sides, so I'm just going to write out my formula. A squared plus B squared equals C squared. And all you do now is just substitute the numbers in. So if A is 4, it's going to be 4 squared plus 10 squared, because B is 10, equals C squared. Well, that's 16 plus 100 equals C squared. 116 equals C squared. And then don't forget the last step. Right, we're not interested in what C squared is, we're interested in what C is, so I have to square root both sides to get rid of that squared there. And my answer is square root of 116, and the question says answer to as an exact value and as a decimal to the nearest tenth. Okay, well, I'm not going to waste your time putting that in your calculator and getting a decimal. You should all know how to do that, okay? So thanks for... Oh, let me do one more. Just I'll do this one as well. Just if you got the hang of this right now, you know that's pretty much it for this lesson. If you're still a little bit unsure, I'm gonna do the line segment CD over here. So I'll do that in right now. So again, if you're cool with this, you know, just go ahead and you know, get on with the lesson here. Okay. So here we go. So the first step is to draw a right triangle. So you just draw a line straight down and then straight across, and mark your right angle here and do some labeling. A, B, C. Okay, well, A, 1, 2, 3, 4, I can quickly figure out that it's 4. B is going to be 1, 2, 3, 4, 5, 6, 7, 8. Okay, so B is 8. So I have 4 squared plus 8 squared equals C squared. 16 plus 64 equals C squared. 78 here, or rather 80, equals C squared. And then finally, don't forget the last step, C equals the square root of 80. And again, put that in your calculator to get the answer to the nearest decimal. All right, thanks for watching, and see you folks in class.